Hi everyone, we are continuing with trigonometric ratios today. So just to start, I would like you to take a look at this first page of notes and complete this as a warm-up. So use your previous notes and fill in all of these questions. So pause the video now and then you can unpause when you're done and check your answers to see if you got what I got. Okay, so go ahead and check with what I got. Hopefully you got the same answers as I did. So you can pause the video now and check your answers. Alright, and the last question asks, would these ratios work for any 45-45-90 triangle or 30-60-90 triangle in Y? And my answer would definitely be yes, because every 45-45-90 and every 30-60-90 triangle has the same ratios. So what we mean by that is for 45-45-90, we are in an x to x to x root 2 ratio, if we remember. And then for our 30-60-90, we are in an x to x root 3 to 2x ratio. Right, so you can substitute x for any number. Alright, so let's actually get into some of our notes today. So first, we're just going to label this triangle so that we can come up with some definitions. So what we're going to be naming this triangle is first over here, I have the A leg. Okay. Then over here, my hypotenuse is what we're going to call C, and then down here, this green is what we're going to call our B leg, okay? Or our opposite leg, as we'll see here. Okay, so just some definitions using our triangle. The first term we're going to define is sine. So we're going to say that the sine, S-I-N-E, of an angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. Okay, so what we mean by that is, using our diagram here, sine of A, so angle A, we always start with our angle, so sine of A is the opposite leg. Okay, so I'm looking at the side that is opposite my angle, so little a in this case, divided by my hypotenuse, which is just C. Okay. Conversely, sine of B, so now I'm looking at angle B, is my opposite leg again, so I'm going opposite, so little b, and again divided by my hypotenuse, so C. A sine will always be divided by the hypotenuse. Alright, our next term is cosine, and the cosine of an angle is the ratio of the length of the leg adjacent to the angle of the length of the hypotenuse. Okay. So instead of going opposite, we're going to go adjacent, just meaning next to. So if I'm trying to find cosine of angle A, again, this time I'm looking adjacent. So before we went opposite, now I'm looking at what is next to. Alright, so just basically the other leg, because I wouldn't be using the hypotenuse in this case. Okay, so I would be using my adjacent leg, so this time B, and again divided by my hypotenuse, which is C. When I am trying to find cosine of B, I am again looking at my adjacent leg, so this time that would be A, and again divided by my hypotenuse, which is C. Okay. And again, you'll have values for these, so you'll end up getting a number, just like we did in our warm-up. Okay, and then last one is tangent. Okay, so the tangent of an angle is the ratio of the length of the leg opposite to the length of the leg adjacent. Okay, so if I'm finding tangent of A, then my opposite leg is A. My adjacent leg is B. Okay, now if we are finding tangent of angle B, then my opposite leg is B. and my adjacent leg is going to be A. Alright, that is all of our definitions. Now, moving on, we have a nifty acronym called SOHCAHTOA. SOHCAHTOA. This is really commonly used. Everyone teaches this and everyone remembers. This is basically what everyone remembers from trigonometry. Right, so what SO stands for is sine being opposite divided by hypotenuse. Oh, I can do better. Okay. Cos stands for cosine adjacent over hypotenuse. Okay, and then TOA, you probably guessed it, stands for tangent being opposite divided by adjacent. So if you can remember SOHCAHTOA, and you can remember what each of these letters stands for, then you'll be in really good shape. So just O is always going to be opposite, H is hypotenuse, A is adjacent. Okay, and then sine, cosine, and tangent. Right, so 3 new functions essentially. Alright, so let's do our first example. We want to find each ratio in simplest form. So first off, I'm starting off with sine of A. So I'm looking for angle A. I see angle A right here. I want opposite, so 24, divided by hypotenuse, so 26. Alright, and we're going to reduce that to 12 over 13. And if we used our acronym, that would have been so sine being opposite over hypotenuse. Right? You can look up here. Okay, sine of B, similar situation. So I'm starting off with angle B. I am looking for opposite, so this time 10 over hypotenuse. So again, I'll use 26. If I reduce that, I will get 5 over 13. Alright, let's do cosine this time. So cosine of A is this time adjacent, so 10, divided by hypotenuse, or 26. So again, we reduce to get 5 over 13, which makes sense, same numbers. Okay, cosine of B, I'm looking to adjacent, so 24, divided by my hypotenuse, which is 26, or 12 over 13. Okay, then tangent is opposite over adjacent. Okay, so I use TOA here, opposite over adjacent. So I go opposite, so 24 over adjacent, which is 10. Okay, we reduce that, we get 12 over 5. And last but not least, tangent of B. So I go opposite, 10, and then adjacent, 24, or 5/12. So basically remember, with sine and cosine, you're always going to divide by your hypotenuse. So you should have your hypotenuse as your denominator for sine and cosine always. For tangent, it's the only one where we're not using our hypotenuse. So you should not have your hypotenuse in your answer for tangent. Alright, moving on. Next, we want to set up the ratio of each of the following using our triangles. Okay, so now we're going to come to some general conclusions about our 30, 60, 45 degree angles. Okay, and we'll end up using these actually quite a bit. This is kind of the fundamental basis of trigonometry, is these values that we're about to find. So first off, I want to find sine of 30 degrees. So I'm right here, or sine of C, we could say, but sine of 30 degrees. So I go opposite, so 1, and my hypotenuse in this case would be 2. Alright, so that's my 30, 60, 90. For sine of 60, I am right here. I want my opposite side, which is going to be the square root of 3, if we use our ratios. So my opposite will be root 3 divided by my hypotenuse again, or 2. Okay. Sine of 45, you could use either one, it doesn't matter. Right, so this will just be 1, this will be the square root of 2. So sine of 45, I go opposite, So I get 1 divided by my hypotenuse, or the square root of 2, which if we rationalize, we get the square root of 2 over the square root of 2. Alright, now cosine. So cosine of 30 degrees, I'm right here. I want my adjacent side, or root 3, divided by hypotenuse, so 2. I have cosine of 60. So my angle is right here. My adjacent side will be 1. My hypotenuse is again 2. So remember that you are always using your hypotenuse as your denominator for sine and cosine. And cosine of 45, again, you could use either angle, it doesn't matter. My adjacent is 1. My hypotenuse is the square root of 2. So when we rationalize, square root of 2 over 2. Okay, last but not least, tangent. So tangent of 30 degrees is opposite over adjacent. So opposite is 1. Adjacent is the square root of 3. We will rationalize this to get root 3 over 3. Tangent of 60 is, again, opposite. So square root of 3 over adjacent, or 1. So this will just be the square root of 3. Okay, and then tangent of 45 is possibly the easiest one to remember. Opposite, so 1 divided by adjacent, 1. Okay, so tangent of 45 will always be 1. You can use your calculator for this. So if you plug into your calculator, make sure that you're in degrees mode. Okay, it will mess you up if you do not use degree mode. If you use radian mode, that's something totally different. So if you plug any of these values into your calculator, you will get the decimal equivalent, or if you're using a fancy calculator, then you will get the fraction. Okay. But again, these values will not change. Sine of 30 degrees is always going to be 1/2. Sine of 60 degrees is always the square root of 3 over 2, and so on and so forth. These values are constant, and we will use them all the time in trigonometry, right? Especially in pre-calculus. Alright, just for a little bit of practice, I would like you to pause the video and try plugging these into your calculator to find an answer. We'll go to the hundredths place, that's fine. Okay, so try plugging in sine of 20 degrees. Again, make sure that you're in degree mode, and you can use really any calculator for this. Any four-function calculator should have trig on it. So go ahead and pause the video here and come back, see if you got what I got. Alright, and we're back, and hopefully you got the same thing that I did. 0.34, 0.34, 0.65. Something I do want you to notice. See if you can spot a relationship between this and this, because we did get the same answer. So notice I used sine of 20, cosine of 70. Is there any relationship you can think of between 20 and 70? Maybe play with that a little bit, see if you get the same answer again. Alright, let's move on. So, some more examples. So now we're going to solve some actual trigonometric equations. First one we have is sine of 40 degrees equals x over 18, and we're going to solve for x. Alright, what I do want you to keep in mind is that this right here, sine of 40, this is just a number. Okay, so sine of 40 degrees is going to be a decimal or a fraction of some sort. So I don't want you to get tripped up because all of a sudden there's different letters here that don't represent a variable. Sine of 40, again, is just a number. Plug that into your calculator and you'll get a value, or you can leave it exact and that's fine. Something that I do want you to keep in mind that students often struggle with, though, is sine of 40 is an operation in and of itself. Sine of 40 is not sine times 40 degrees. Okay, so you cannot like divide sine to both sides. That's not how sine works. Sine is an operation. Okay, just like multiplication or division, you can't just get rid of the multiplication sign. You can't just get rid of this fraction bar, right? So you cannot divide sine out for whatever reason. I always have students that think that you can do that, but you cannot. Sine is an operation. So sine of 40, they're pretty much stuck together until we learn about the inverse of sine. Okay, so for now, I'm going to isolate x by multiplying both sides by 18. Right, so I'm just going to multiply by 18 both sides. So I will get x equals 18 sine of 40 degrees. And you could leave your answer like that. It's exact, and that's fine. If we plug this into our calculator, we would get x equals 11.57. That's also fine. I would specify on any exam if I'm looking for you to leave your answer exact or to how many decimals I want. Okay. All right, next one. I have cosine of 52 equals 19 over x, so I want to solve for x. So I would probably multiply both sides by x and then divide both sides by cosine of 52. So again, I'm keeping in mind that cosine of 52 is a unit, right? So I'm going to move the cosine and the 52 together. So x will be 19 over cosine of 52 degrees, or 30.86. Okay, and last but not least, over here I have tangent of 25 equals x over 112. So let's multiply both sides by 112. X will be 112 times tangent of 29 degrees. We plug that into our calculator, we get 62.08. Alright. Next example. So, we want to find a B, and eventually we want to find a C. So, I need to start with what I am given. In this case, I have 25. Okay, so this is the angle that I'll be focusing on. I have 5.1. So I'll call AB, let's call that X, and let's call AC Y. Okay, so I need some relationship between X and 5.1. Or in other words, I need some relationship from my angle. Okay, I'm always considering where my angle is. I need some relationship between my opposite and my adjacent. So I am remembering SOHCAHTOA. I have a relationship right here between opposite and adjacent. So I know that tangent of 25 is equal to x over 5.1. So x will be 5.1 times tangent of 25, or 2.38. Okay, now I need a relationship between my adjacent and my hypotenuse. Okay, so I look over here, adjacent and hypotenuse, that's going to be cosine. So I know that cosine of 25 is going to be 5.1 divided by y. Same thing as before. This time let's get fancy with it, so let's invert both sides. So I'm just going to, this is divided by 1, switch. So I have 1 over cosine of 25 equals y over 5.1. You can do that. Now I can just multiply both sides by 5.1 and get 5.1 divided by cosine of 25 degrees. In other words, 5.63. Alright. And the last example, we need to again find each length. I would like you to pause the video here and see if you can work this out on your own. So go ahead and pause the video and come back and check to see if you got what I got. Okay, and hopefully you got the same answers that I did. Just quick note, if it's not immediately obvious to you where your hypotenuse is, always keep in mind that your hypotenuse is opposite to the largest angle. And for a right triangle, that will be the right angle. Okay, so your hypotenuse will always be opposite E, or wherever the right angle is. Okay. So I need a relationship between 50 degrees and 4. So for ED, I set up tangent of 50, solved to get 4.77. For DF, I set up sine of 50 and was able to solve and get 5.22. Okay, so we have some trigonometric practice here. This is your homework, so please work on this. Let me know if you have any questions. Otherwise, have a fantastic rest of your day.